welcome to the session today. So this guest lecture is the fourth guest lecture series that is conducted by Department of Information System. And today we will discuss the topic about the ordinary and the extraordinary of process mining. But before that, I would like to share my screen first. Mr. Paolo, is that okay if I share my screen? Yeah, thank you. Okay, during the guest lecture session today, we will have some agenda. The first one is the opening for the participant with the speech of the head of the Department of Information System. And then the agenda will be followed by the lecture session. And the lecture session will be divided into two sessions. The first 45 minutes will be lecture section 1 and will be followed up by the Q&A and the Q&A for the session 1, and then we continue with the second lecture session, followed also by the Q&A session, and then the last one is the wrap up and closing. And today we will have Bu Mahendrawati as the moderator. She is the Associate Professor of Department of Information System ITS, and previously she has completed the bachelor degree in Industrial Engineering ITS before she continued master degree in Operations Management and Manufacturing System, University of Nottingham, UK, and then finally got her PhD in Manufacturing Engineering and Operations Management, University of Nottingham, UK. She's experiencing for some various lecturer. For example, the system enterprise and also business process management, process mining, etc. in information system department. And previously, she also worked as the research associate, Nottingham University Business School, and working in a project together with the University of Nottingham too. And she has a lot of publications. The last one is the impact of social media functionality and strategy alignment to small and medium enterprises. And then also model for BPM implementation assessment, evidence from companies in Indonesia. So without further ado, I will let Bu Mahendra to moderate the session. Please welcome Bu Mahendra.
Thank you. Thank you very much, Bu Ika, for the kind introduction, and welcome, Paolo. I hope that you don't mind I called you with your first name. And before I start with this session, I would also invite Dr. Mujahidin as our head of department, if you would like to say some words. Thank you.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Selamat malam para hadirin, Bapak Ibu semua di acara guest lecture malam hari ini ya. Good afternoon, Prof. Paolo. Ladies and gentlemen, this afternoon I'm very happy where our department is visited Prof. Paolo. Prof. Paolo is from Università degli, Studi in Milano-Italy. Thank you very much for Prof. Paolo. Today, Prof. Paolo present and sharing knowledge about the ordinary and the extraordinary of the process mining. So we hope this sharing can give me knowledge about process mining. And then I think I must tell to Prof. Paolo that Associate Professor Dr. Mahendrawati is a candidate to become a full professor in our department for business management. Yeah. Therefore, I expect to the support from Prof. Paolo to Dr. Mahendrawati. Yeah. Okay.
Sure.
Thanks
My
again.
pleasure.
Yeah. Okay. Thanks again from Prof. Paolo. We hope you always healthy and happy. Terima kasih juga pada Laboratorium Sistem Enterprise ya, dan Bu Mahendra serta Bu Ika dan panitia semua. I'm sorry if there are any inconvenience from our departments. Okay, thank you, Prof. Paolo.
Thank you so much for this kind introduction, and give me just 1 second for sharing my screen.
Can we introduce you first?
Oh, okay, sorry. Sure. Please go ahead.
Okay. So This is my job. After this, you can take over. So Professor Paolo Cerevolo is associate professor, and I'm sure soon enough will also be a full professor in Department of Computer Science, Università, degli, Studi di Milano. And his experiences are, I think you started in 2006 until 2019 as assistant professor in the Department of Computer Science, University of Milan. And also he has been a visiting professor in the bachelor course. I think at the moment you are in Germany for that purpose. And then you have taught also a postgraduate course at Università degli Studi di Milano in Master in Digital Humanities, and also principal investigator for strategic investment plan. And the project title is Interactive Learning in Process Mining. So clearly I invited you for the right reason. And for education, he has a national scientific habilitation and also a PhD in computer science from the university that you are currently working on, and master in computer science in basis methodologies for human science, and bachelor in philosophy from Catholic University of Milan. Professor Paolo Cerevolo also has a lot of international publications, and most recently appears in IEEE transactions on services computing, and also in concurrency and computation. I'm sure there are many things that we could learn from Paolo. Because of the time, I would not read the whole CV. I will now hand you over to start the course.
Okay, thank you so much. I need to share my screen, 1 second.
Sure.
So, of course, I also would like to thank you for this invitation. These guest lectures that you are proposing, I think are working very well in disseminating important topics related to process mining and process management. So it is really a pleasure for me to be part of this great organization with the audience that you are able to create around these topics that we know are not so easy, but very important in today's organizations. So I decided to title this presentation The Ordinary and the Extraordinary of Process Mining, because the idea was a little bit to have an initial part where I'll try to tell you what is typically presented about process mining. Also, everything is necessary to know in order to be introduced in the topic. But I also would like to propose you some aspects that are more related to the research activities that we have conducted in the University of Milan. So bringing a little bit our point of view on the discipline that not necessarily is the same point of view that you may have in other research labs, but I think is bringing some original contribution that may be of inspiration for you, hopefully. Sure. So this just quickly to tell you something about me, as already mentioned, I'm associate professor at the University of Milan. I developed researches in different areas like knowledge representation initially, with some attention on process monitoring and then process mining. But we also try to have an attention on the integration of technology in general. So this means also connecting monitoring activities with the analytical activities that must be conducted. So having understanding of the connection, for example, with machine learning or with other knowledge acquisition techniques that you may have, and also the human side that is always very important, no? Understanding which is the impact in terms of the acceptance, in terms of the understandability of the technology. So here you have, let's say, an official picture of me, more or less. I'm dressed the same way that today. Here you have maybe a more real picture of myself. You know, you can see I'm taken by some side thinking, and so just to say that, of course, the set of interests that I'm trying to address is quite large. You may have a view by looking to my identity on internet, no, using Scholar or using Twitter, if you like, of ResearchGate and so on. However, let's go on process mining. So process mining is a family of techniques in the field of process management. The idea is to support the analysis of business process management based on data. Now, so a picture that is often used is presenting process mining as the intersection between business process management and data mining or data analytics. I think is quite interesting and quite relevant, because it shows you that from one side you have the algorithms, you have the analytics, but from the other side you also have the business and the management methodologies with their goals, where their indicators, and these two aspects must be connected. Now, I think it is important to stress a little bit on it, because sometimes, especially people that are coming from computer science, like me and my colleagues, tends to look to process mining simply as an algorithmic discipline where, I don't know, you have to work on proposing new algorithms or testing the properties of these algorithms, but this is not exactly the scope of the discipline. The scope of the discipline is being in support to business process management. So we never have to lose the connection between the analytics that we want to propose and the methodology and the procedure that we have in business process management. It is, however, true that you can look to process mining also from a wider perspective, no? Because process mining is using data that are generated by information systems in order to develop some analytics. And you know that today we are generating a great amount of data that are about events. Now we have data about events that are generated everywhere in the internet. And these data are quite interesting because they are telling us something about the content of an event, so what this event is addressing, but they are also bringing a lot of information about the metadata, no? So something that is not directly related to the content, but is about who is using this content, no? Or, for example, in which context I'm using this content, which are the resources that are required in order to develop this content, and so on. So we can speak about the Internet of Events in the sense that we have today the availability of a large set of data sets describing events, and process mining can be a tool we use in order to analyze these events. A tool together with others, because of course you may also use additional data mining or machine learning techniques in order to analyze the events generated by the information system. But process mining has developed a set of algorithms and tools that address specific problems. So if we know which are the problems that can be solved by process mining, we could adopt him also outside the scope of business process management, in any area where we are interested in observing events that are generated by information systems. Other common picture that is used in order to introduce process mining is this one that is coming from one of the seminal works on process mining by Professor Van der Rast. And you can see that process mining is, as we said, about using data that are generated by the information system. We typically refer to this data as event logs, because they are collecting the events generated by information systems. And we want to use this data in order to support the analysis of the process executed by organizations. So, of course, you know that the processes executed by the organization will follow some specification, some specification that is provided by the organization. If this specification is somehow explicit, we can speak about a model. So we have a model that is guiding the organization in developing a process. So this, of course, is an abstraction in front of the real world. So we are not describing everything using specification. We are describing only a subset of the real world. But it is of great interest to compare and analyze the event logs and the models. So the event logs are somehow providing information on what is actually observed in the organization, while the models will tell you what is prescribed in the organization, or which are the specifications that we are expecting people and the organization in general will follow. So by comparing these two information, we can get a lot of interesting informations. And the three typical tasks that are proposed for process mining are discovery, conformance, and enhancement. I, however, would like to propose this picture for introducing the process mining task, because I think it is a little bit more up to date compared to the current result in this discipline. Actually, process mining is not just about process discovery, conformance checking, and enhancement, because there are important aspects related to, for example, performance mining. Performance mining, I think, is really a key set of techniques to connect process mining with business process management. Now, we don't have to forget it, and we don't have to think that process mining is just about algorithms that can discover the process or run conformance checking techniques. And then another group of tasks that are very important is variant analysis. Variant analysis will be about understanding better the event logs, so profiling the event logs and understanding how these event logs could be addressed in order to run performance mining, process discovery, or conformance checking. So if we want to describe the process mining task, I think we should consider at least these four groups of tasks: variant analysis, performance mining, process discovery, and conformance checking. So I would like to try during this lecture to give you an introduction to these four groups of techniques. So this will be a little bit my goal. And in the second part, I'll try also to show you some connection between the techniques that are relevant in order to develop consistent analysis using process mining. So this is a little bit the goal. As we said, in the first part, we are going to introduce the basics, and in the second part, we are going to provide something that is a little bit more advanced. So let's start from the functions of management. This is a little bit your field, so you know better than me this part. But I think it is important starting from this, because as I said previously, we never have to forget that process mining should support business process management. So should start from the methodologies that are used in business process management. And for example, when we speak about the function of management, you know that we have planning, organizing, staffing, leading, and controlling, for example, no? So planning will be about defining the strategic goals the organization have to follow. Then we decide which actions the organization want to implement in order to get the goals defined at the planning level. And then, of course, you have to do some leading activity, for training, inspiring, and motivating people. You have to do important activities in the area of staffing, recruiting, and developing the skills of your employees. Orthogonally to all these activities, you have controlling. Controlling is, of course, very important because it will allow you to understand if the organization is actually moving according to the plans. And process mining is part of the control function. So it's something that should be orthogonal to the different, to the other dimension. And process mining should support the controlling in the organization. So this means, you know better than me, that we need to use process mining in order to support the evaluation of the goals of the organization and the decision making. Both these functions are very important. From one side, I want to evaluate. From the other side, I want to understand if there are aspects that I can support in taking decision, because we know that the control can apply to different levels. We have the strategic, the operational, and the tactical level. The strategic is about the high-level goals. The operational is about the activities that I'm going to implement. Are I effective in implementing my activity? The tactical is about taking real-time decisions. So process mining should be able also to support this level, the tactical level. And in general, when I do controlling, I have to start from some measures that I want to use. For example, I can use performance indicators in order to measure the operational level, or in order to measure the strategic level. And you know that these indicators can be computed starting from observations that are connected in the organization. So process mining is exactly supporting this kind of activity. I start from the observation, from the data that are generated by the organization through the information systems, and I want to use it in order to verify my performance indicators. So I can have a performance indicator at the strategic organization or controlling level. So in general, if I took the goals that are defined at the strategic level, and I combine these goals with the observations about my performances, I can have something that is useful for the strategic control. If I'm combining the observation with the specifications that are provided by the organization, I can have indicators that are related to the operational and the tactical control. Often process mining is focusing on this aspect, not the operational and the tactical control. In combination with other techniques, it could be very useful also for supporting the strategic control. Okay, so of course, this will connect you with methodologies like the balance scorecard that you define your goals in different functional areas, and you want periodically to monitor how these goals are supported. So let's try to see how process mining can support the evaluation of performance indicators. So you know the notion of performance indicator, I think, no? So we have, first of all, to define a measure. No? We have to define this measure by putting in relation one of or more dimensions. And we also have to define an objective. No? The objective is the thermal comparison that we are going to use in order to verify if the performance is achieved or not. And also, you know that you have a lot of references, let's say models and materials for the performance indicators to be applied. So it's not something that you have to invent, but it's something that you can take from the literature. So which kind of indicators you can compute using process mining techniques? So the most common dimension that may be monitored using process mining are time, cost, and quality. So I would like to go quickly on this part, but just to remind you, example of indicators that are used in connection to the time dimension, you can have processing time. No? It's the time taken in processing an activity, or you have waiting time. It's the time between two activities. So one big part of the operational management will be reducing the waiting time between the activities. And you can speak about the cycle time when you are taking the lead time. No, the lead time is the sum of all the processing time and waiting times, and you remove the transition time, so the waiting time or the wasted time. This gives you the cycle time, and you can, for example, compute the cycle time efficiency. That is a very important indicator that will tell you how many time in my organization is devoted to value-adding activities, and how many time is wasted time is something that is not really significant for the achievement of the goal. No? So this is a very crucial indicator that you would like to support using process mining techniques. So maybe you will ask yourself, okay, but I know already this stuff, I can compute the cycle time technique without using process mining. But I'll try to show you that using process mining, you could be more effective in computing this kind of indicators. So you have other indicators that maybe are related to the costs, no? So cost of processing time is probably the most interesting at the operational level, because the cost of the acquired materials or the raw material is something that is more dependent to the supply chain function and not to the optimization of the operational level. You may have resource optimization, that is another very important indicator that can be supported by process mining techniques. And you have also quality. Quality is, for example, about the defect rate of process, how frequently you are producing some defect in your production, or the durability of your products, and so on. This is also another dimension that you could consider. And then you may have other, like inter or arrival time, for example, the average time between two new cases. That is another very important indicator that can be supported by using process mining technique. Okay, so now let's dive a little bit more into process mining area. So we say that process mining is about using data from the information systems in order to assess the organization, no? And for example, assessing the performance indicators. So let's have a look to the data that we are using in process mining. These data, as we said, are typically referred as event logs. Now, event logs are the logs generated by information systems. So the information that we have here is then an information that is related to the events that was generated by the organization. As we already mentioned, this is very relevant for us because it provides us a view on what is actually executed by the organization. No? So we can observe the performances of our organization by reading these event logs. And by observing what is actually implemented by the organization, we can compare it with what is expected. So, for example, my goals, my specifications, and we can get important insight. So it will be, process mining will be about using event logs, and at the same time will be about comparing event logs with specifications, because in these specifications, you have the expected behavior, the behavior that is prescribed for the organization, and so we want to compare it. Specifications may be in many forms. You know that they can be collected implicitly, explicitly, using natural language, using rules, using models sometimes. So typically in process mining, we consider models because they are, say, formal specifications, but we could also consider other form of specification that may be translated in some formal way. For example, rules. Rules may be very important, a very important source of specification to be used in process mining. However, let's think right now about, for example, a process mode. So if we have the data and we have the models and the specification, we can compare them. This is process mining. So let's introduce something about the terminology that you must know in order to be oriented in the process mining literature. So, for example, event log. So event log is a collection of events recorded by an information system. We already mentioned. So each event log is describing an activity, a task, is describing the time this activity was executed, plus additional information, like, for example, the resource that was required to execute the activity. Another important notion that we have in event logs is the notion of case. A case is a collection of events related to the same process execution. Now, this is an important difference between the representation level used by process mining and the representation level used by many other data mining or machine learning techniques. Because in many data mining and machine learning techniques, we start by analyzing collection of events. And let's say each row or your data set will be an event. Here in the event logs that are used in process mining, because we want to connect the data with the business methods and the organizational level, events are collected in cases. No? So we have sequence of events that are related to the same process execution. This is a very important notion that will allow us to get important insight on our data sets. So, so each case is a specific execution. We can look to all the cases that are following a same sequence of activities, and we call this a variant, or sometimes also a trace. Now, a trace is a sequence of activities. When we have two equal sequences of activities, we speak about a variant. And variant is very important in process mining. You will see that I will spend some time on this notion because it's really crucial. last notion is about a process model. So this is an abstraction that you generate on the events that can be generated, that can be produced by the organization. No, is an abstraction because you are trying to model a general behavior. So using a set of logical specification, you want to describe in a more general and synthetic way the steps that are prescribed for a specific business process for a specific organization. So one other technical notion that is very important in process mining is the notion of behavior. So what is a behavior? So behavior is basically what can be executed by the organization or what is prescribed by a model. So in, let's say, at the first level, you can think at the behavior again as the sequence of activities that can be performed. So in an event log will describe a behavior of the organization because it will tell you which are the sequences of activities that are actually observed. At the same time, a business process will also describe a behavior because it will tell you which are the sequence of activities that are legal for the organization, or for the specific business process. And you can compare the two set of behaviors. So are the behaviors that are observed consistent with what was prescribed, or at the same on the other side, are my models able to capture what is the real behavior that the organization is developing? These are a little bit the general questions that we would like to be able to answer. And so you understood that event logs are the initial source for developing or all the analysis that we have. And an event log is organized more or less in this way. In each row, you have the events that was recorded. And according to process mining algorithms, in order to describe an event, you should have at least three attributes available. One is the activity that was executed during this event. Another one is the timestamp when this activity was executed. And the third one that is absolutely mandatory is the case ID. So during which process execution the activity was executed. You could have many other attributes, like, for example, human resource that was involved, or I don't know, additional information that is describing the event, but the very mandatory items are case ID, activity, and timestamp. This is somehow critical because not always your data set will provide the case ID. Think about an email. The archive of emails that are collected by an organization may be an important source of information about the activities that are executed by an organization, but it's not so easy to understand which is the case ID. Maybe the case ID could be the subject, because if I have a sequence of messages that are related to a same subject, or for example, guest lecture organization, you can see how many people was involved in the organization of this activity. However, you know that the subject is not always readable because people can change it, or you may have multiple, and so on. If possible, based on what we said on the performance indicators that we would like to support in process mining, it is very important if we may have the timestamp for the starting of the activity and the timestamp for the ending of the activity. Because this way, we will be able to compute the processing time of an activity, and we will be able to compute better the waiting time between one activity and the subsequent. No? So if it is possible to have the start time and the end time of activity, this will be very valuable in order to have better results in your analytics. And why are we using process mining? You have many use cases, for example, process optimization, process discovery and automation, conformance and validation, or simulation. So you may have many other use cases. If you are interested in understanding better why the organization are using process mining, for solving which kind of problems, I suggest that this global process mining survey by Deloitte, where you have a view on, is a partial view because probably is a little bit biased on the Western countries, but you have a view on how the real organization are using process mining. You can see, for example, many are using them for process improvement or for improving the transparency in processes, and so on. So I think this could be a good reference for you. Okay, so we say that we would like to introduce the process mining task, and let's go ahead because time is running. The first point is performance measurement. No, we say that this is an important point of connection with business process management. We don't have to forget that process mining algorithm should be designed in order to support performance measurement. I also would like to spend a few seconds in order to stress the fact that why process mining is really useful for performance measurement. Because doing performance measure in general on the process is not something that is really so reliable. And probably you know, no? For example, mean values are not so relevant when you take a process in general. So let's say that your process is supplying a product or is serving a customer. So this is the process in general. And when you analyze it using your Banso card, for example, here is a screenshot from Power BI, you may have information about, for example, the mean time that is used for this process or the median lead time of this process. Is this relevant for you? Actually, it's not so relevant because we should understand that processes are not organized according to a normal distribution like you may have for other statistical phenomena, like, I don't know, the weight of people in a nation. And also, another point is that the term of comparison that you are using is really critical. And process mining helps you in defining the right term of comparison to be used in order to assess your process. Let's enter a little bit on this point that, in my opinion, is very important. So first of all, mean values and median values are not so relevant. You know that very different distribution, like you can see on the right side of the picture here. So very different distribution may have the same mean. So the mean value don't tell you a lot about a distribution. And also, this is particularly true when we are working with non-normal distributions like squid distributions or Pareto distribution that are very common for human activity. Now, you can see that, for example, in a squid distribution, the mean value is not representative of the most frequent value. And even the median value may not be so representative. And you will see that very frequently in process execution, so in event logs, the distribution is not a normal distribution, but is a Pareto distribution. So the ability of analyzing the event log give you important insights on how to analyze the process itself. because the analysis should be done case by case or variant by variant eventually, segment by segment, not taking the overall process in general. And the other point that I would like to mention is also the term of comparison, because we know from the scientific method that if we want to compare to observations, to phenomena like my process, the performances of my process in 1 year with the performance of my process in another year, or the performance that I have in a department, the performances that I have in another department, I should first verify if the two groups are comparable. No, we know this from the scientific method. And if the two groups are not comparable, so in principle, they should be equal except for one variable, we know. We also know that in, let's say, social science and the real world, it's very difficult to have this kind of situation that is a sort of in vitro experiment, but at the same time, we cannot simply say, okay, let's me compare my process this year with another year without having applied the right methodologies in order to understand how these two observation distribution could be compared. So process mining, for example, is supporting you using variant analysis. Variant analysis is an important tool that is provided to let you understand better the distribution of the event log and compute performances, not on the entire process, but on specific variants, for example, on specific segments that may be more significant for analyzing the process. Why this is very important. So, sorry, let's first recall what is a variant. Now, a variant is a collection of cases following the same trace, the same sequence of activities. So if you group the cases in variants, you are going to group cases that are comparable between them because they are following the same set of sequences. So in a variant, it's becoming more significant to say, okay, my lead time, my mean or median lead time is the following. Because you are comparing cases that are comparable, that they are similar, at least in terms of the sequence of activities that they are implementing. But you know that the variability you may have in a process is very high, so you may have cases with very different sequence of activities, no? That are not comparable in terms of their performances. Using variant analysis, you have a mean for obtaining better terms of comparison. And we can even extend this notion, no, relaxing a little bit it, not considering only the sequence of activities, but consider other properties. No? So, for example, you can say that a variant is all the cases that have the same start activity, or all the cases that include a specific activity or that conform to a specific performance level, objective, and so on. So this is a very important notion, in my opinion. So I would like to stay a little bit on this. So here you have, let's say, an example of what is a variant, but I think you understood. No? For example, in this case, we have case 2 and case 6 that are following the same variant because they have the same sequence of activities. And the distribution of variance in an event log is typically following a Pareto distribution. No? That means that 80% of the cases are can be described using 20% of the variance. Because typically you have some variants that are very common in your process. Then you will have other variants that are probably very rare. Now maybe they are executed just once in your process, And of course, you cannot account them in the same way. You have to identify those that are describing, let's say, common behavior, typical behavior of the organization, and those that are representing exceptions or maybe unique examples that you may have in the history of your organization. And so here we have an example of how the frequency of cases and the variance may be organized. And this is, in my opinion, the first analysis that you have to do when you use process mining. So observing the variance that you have in your event log and study a little bit their distribution. So, for example, you can have a set of variants that are describing a lot of cases. Now, this is, let's say, the common behavior that you may have. So, for example, if you are interested in automation, this segment A could be the part that is useful to be automated, no? Because using a limited set of variants, you are able to support a big number of cases. Then you have the segment B, that is a segment where you need more variants in order to get the same amount of cases. And in segment C, you have something where more or less the number of variants is very close to the number of cases. Now, often you may have a variant for with a single case, so single execution. For example, if you are interested in automation, this segment C is the segment that you will not consider for automation because it's absolutely too costly to invest in automating variants that maybe was observed only once in your event logs. No? So this is the part that will tell you which set of which cases, which set of execution still require the availability of a human in order to be executed. And okay, so you using this kind of Pareto distribution, you see that median and average values are not so significant. Why median and average value become more significant if you compute it on a specific variant. And the process mining tools typically provide you a view like this that allow you to observe the distribution of cases. And you can see for this example, this is a real example. I already filtered out some of the most common and frequent variants, and you obtain something like this. You can see that you have a lot of variants with a single case, a single execution. And once you have analyzed the variants that you have in the event log, you can start using them for performance analysis or also for control flow analysis. Because, of course, your performances can be computed using the traditional indicators that you have, like we said, cycle time efficiency, overdue cases and stuff like this. But you can also, and this can be done on different perspectives, the case, the resources, the task, and so on. But another interesting thing is you could consider the patterns, the control flow patterns that you have in the organization. So, for example, do you have repetition of the same work? Are you reworking some activity frequently? Or do you have something that is executing in parallel or not? Now, these kind of patterns may be of interest and could be analyzed on the variant. So I could observe if in a variant I have specific patterns that are not observed in other variants. But in order to do it, we need to develop techniques that are able to observe the temporal behavior that I have in my in my data, no? Because you may have some simple pattern that can be easily evaluated using query. No? For example, does this case include the rebuild activity? This is a pattern, and it's very easy to be computed. But you have other more complex patterns that require you have a temporal representation. No? So you use some tool that is rooted on temporal logic. No, and these require that we develop process models. No, that we are able to work with process models. So let's enter on this part that is about using event logs in order to discover process models. So I'm sorry, but I have now to go a little bit fast, but I hope these slides that I'm giving you can provide a reference for you if you want to go in more details. So it's again about comparing the expected behavior with the observed behavior, no? But in order to generate this model that will allow me to observe more complex patterns, you have a set of techniques. For example, you have direct follow graphs. No? These are very much used by commercial tools, for example. So you will have a representation like this one where you see all the activities that was executed and how they are followed. But because this is constructed only taking the subsequent event, it is well known that this kind of representation brings relevant biases. Now, for example, the frequency that is observed here is about the direct follow relation, but I don't know if, for example, here, I don't know how many of these, no, we know that three cases include a transition between decide and reinitiate the request. But I know this, but I cannot know how many are coming from a path that is following this one, or a path that include a repetition, include the flow like this one. No, it is something that is not provided by the direct form. And also this kind of representation describe parallel activities as loops. So when I have a loop like this one, this could be a loop, or it could be simply two activities that are executed in parallel. So the process mining community developed more sophisticated techniques in order to identify the temporal constraints that are described in a process model. For example, a process tree will provide you with the possibility of defining if the activities are in sequence, are connected by an exclusive choice, or by a parallel composition. And you have many algorithms that you may use in order to define these techniques. You can also use Petri nets. Petri nets are very much used in order to represent this kind of patterns. And yeah, so the process mining community devote a lot of time in developing algorithms able to detect this kind of model. For example, one of the most important from an historical point of view is the alpha algorithm. The alpha algorithm is observing the starting from observing the relationship of followish relation between activity. Now, for example, B follow A, C follow B, D follow C, and by observing this relation, it has a set of rules that will allow him to understand this. For example, two activities are in sequence. So A and B are in sequence if I can observe B following A, but I cannot observe A following B. Or I can also discover another dependency between A and B it could be that A and B cannot be followed one after the other, no? And this is observed when I have B that never follow A, but I also have A that never follow B. So in this case, the two activities are disjoint. Or I may have parallel activities. Parallel activities are when B is following A, but also A may follow B. So you understand that here the algorithm is taking some assumptions on the sequences that are observed in the event log. For example, when you have A that follow B and B follow A, it will create a parallel sequence. So, no? We consider the two activities as parallel, executed in parallel. This may be true in many situations, but you still have situations where this is not true. Maybe simply the two activities are in a loop. Now, if I have A, B, A, B, A, B, A, B, you will easily understand that this probably is not two parallel activities, is a loop that is repeated several times. So the alpha minor start from analyzing the event log, extracting all these dependencies, relations, and mapping them, for example, on a Petri net, no? In order to obtain these sequences, these excluding path, or this parallel behavior that you have. And at the end, you obtain a model like this one. But alpha minor has its limitation. For example, it's not considering the frequencies of activity, so it is very much prone to noise. If you have, I told you, you may have a lot of variants that are observed only once, and the algorithm is going to consider all these variants in order to construct the model. So the model will be very complicated, but maybe this complication is explaining only a not relevant part of the behavior we have. So using the heuristic minor, you are filtering out the infrequent behavior, and this provides you with some improvement. Let's say the family of algorithms that is performing better is the family of the inductive minor algorithms. These algorithms are better than alpha minor and inductive minor in defining the relationship that you have between the activities. So in particular, identify if you have a relationship of exclusion or a relationship of conjunction between the activities. So you can also have other kind of algorithms based on, for example, genetic programming and other advanced techniques. One important thing to be done is to be mentioned is the fact that you don't have a single metric that you can use in order to evaluate a process discovery algorithm. You have a set of metrics, like, for example, recall or fitness. The process mining literature often speak about fitness, but it's the same metric that in other disciplines is referred as recall. This is about the fact that the model that you discover allow the behavior that is seen in the event log. But you may have also the precision. So in this case, you are interested in observing if the discovered model don't allow behavior that is not observed in the event log. You also have generalization. And generalization is about allowing some more behavior that what is in the event log, and you have simplicity that is about constructing a model that is not too complex to be understood. A good algorithm should be able to balance between all these dimensions. Now, because if you may get, for example, perfect precision, but very bad simplicity or generalization. So in this case, the model is consistent with the algorithm, but will not be very useful for a human reader. And in order to understand better these notions, we have to speak about the fourth task, that is conformance checking. Conformance checking is, again, comparing the observed and expected behavior. No? So we have now the event logs, we have the, we know how analyzing the event logs using variant analysis, we have the models, we want to compare them. And this is conformance checking. No? I want to observe if the behavior that was recorded in the organization is conformant with the behavior that is prescribed by my models. And yeah, so this is conformance checking. It could be done using models, or it could be done using rules. In order to don't make things too complex, I'll now focus only on techniques based on models. And the idea in these techniques is basically that I'm using the event log, try to understand if I'm able to generate the traces that are in the event log following what is specified in the model. And I can compute, no, I can verify how many deviations I have between what is in the event log and what is in the model. And this will allow me to identify, for example, behavior that is not that is considered dysfunctional for the organization, or to identify behavior that is new behavior that, for example, was never specified by the organization, but is actually implemented by the organization, and we probably could consider to specify it in our models. So now that we have this notion that we can compare the event log and the process model, we understand better the notion of fitness and precision. No? Because in abstract term, fitness and precision are about, basically, in the case of fitness, is about comparing the intersection between the model and the log with the log. Now, in order to understand if this intersection is covering the entire log, or you have a part of the log that is not described by the model. While precision is about comparing this intersection with the model. So it will be about understanding if what is in the event log and in the model is everything is described by the model, or the model allow for additional behavior that is not in the event log. So in abstract terms, it's very simple to understand these two metrics. Implementing them is much more complicated because a model can generate infinite behavior. Now, it is very simple to show it by simply providing a loop. If you have a loop, like in this case, so you may have A, B, C, and this sequence may be replicated as many times you want. So the set of traces that are generated by the model is infinite, and we call the set of traces of a model the behavior of a model. Also, this making a little bit more difficult the situation, also the set of traces that are not supported by the model may be infinite. So how are you going to compare a finite set, like the set of traces that you have in the event log, with a set of traces that is potentially infinite? So this is the challenge, no? And so you have different, okay, so you know that the models could be also provided by reference models that I think you are expert in generating them using BPMN. Petrinet are a formal reference for describing these models, but let's now have a quick look to how we can implement fitness and precision using an algorithm. So the idea is, okay, let's try, for example, to replay the event log using the process model. And let's count how many times I've got a deviation. A deviation, for example, in terms of the number of tokens that was consumed, or tokens that was not consumed, or number of tokens that was produced. And by combining all this information that you generate, you have a measure of the fitness between the process and the event log. Let's see very quickly an example here. No? So from left side, you have the process model, and right side, you have the event log. So you try now to replay it. You start from A. Okay, you have A in the model, fine. You can continue with B. You have B in the model, so you can continue. Then it is about D. Okay, fine, you go ahead with D, and you take into account how many tokens that was consumed. The tokens are these black markers that you have here in the Petri net. So you go ahead and you arrive until at the end where you can compute, execute the entire traces. And in this case, the model was able to execute this trace. So let's go ahead with another one. No, and you continue this way. And for example, you can discover that with some traces, you are not able to replicate exactly what you have in the traces following to the model. So this is a deviation that you are going to account and you are going to use in your metrics in order to compute fitness and precision. Like fitness is, the research community has a good convergence on how computing fitness. In terms of precision, there are more divergences. So people have different approaches for computing precision. In general, you have three families of techniques that you can use for process mining. The replay technique, that is the one that I very quickly demonstrated, but you also have trace alignment and behavioral alignment. And so we understood that using this kind of algorithms, we are now able to compare the event log and the specifications, like, for example, the model. However, be careful that here we again come back to a point where the, let's say, the inputs from the business process specialist must arrive. So you cannot solve by the algorithms the problem related to what you want to assess using process mining, because you may have two very different goals. One goal could be, for example, I want to identify dysfunctional behavior. So in this case, I start from the assumption that my specifications are right. And if I have something in the event log that is not conforming to the model, I consider this dysfunctional. And so I need to put some intervention to enhance my process in order to avoid producing this kind of dysfunctional behavior. But you could have a completely different goal. That is, okay, what I am observing in the event log is additional behavior that I want to integrate in my specification. No? So in this case, the non-conforming traces will be unspecified behavior that I should consider in the specification of my models and my instruments. So you understand that you are using the same tool for two completely different goals, and this is the process mining specialists that have to tell us which is the goal. And be careful, because often in the same process, in the same event log, you have both. So you have part of the non-conforming traces that are dysfunctional behavior that you want to consider like exception to be avoided, and you have part of the behavior that is unspecified behavior that you would like to integrate in your specifications. No? So this let you understand how important it is that the business process specialists drive process mining methods. Okay, so sorry if I'm a bit late, but we finally arrived to the conclusion of the first part, and I'm very happy to listen your feedback and questions.
Thank you, Paolo. Very interesting part, and we already have quite some questions. So I would like to invite Afira. Would you like to ask your question?
Oh yeah, yes, ma'am. I have a few questions for you, sir. So the first question is, I have read about process mining in one of Professor van der Alt's book, and one of the things that he mentioned is the minimum components for making an even log are a case ID, an activity timestamp, and in some cases, the resource. So what I want to ask is, in your personal experience, are there any other attributes that are necessarily crucial but rarely mentioned in the event logs, and what are their effects to the process mining results?
Thank you. Very interesting question, because yes, we say the traditional items that are considered are the activity, the time, the resources often considered because you are interested in computing the workload of the resources or the work capacity that you have in the organization. But there are many others fields that may be of interest to compute performance metrics. For example, think about the cost. How costly was executing these activities may be very relevant if you want to compute some indicator that is related to the cost. Or I do not think about analyzing somehow the content of an activity, like for example in design in design activities where, for example, you want to design an artifact. It could be a piece of an engine or whatever. So you are exchanging some documentation about it, and these are documents that can be attached to the events, and you could use in order to understand better which is the flowing of these documents into Pro. So there are many additional attributes that could be considered, and my suggestion is the following: start from the performance indicators, that are also your specialization, if you want. So once you have understood which are the performance indicators that you want to compute, then you can identify the attributes that you would like to have in your event log, and you can go to, let's say, a computer engineer and to say, okay, I would like to have this kind of data. Is it possible to extract this data from the information system, and how could we compute metrics on these indicators?
Okay, because Afira has another questions, two other actually, but I would like to rotate a little bit. Can I ask Rizky if you would like to ask your question directly, please? Is Rizky here? Well, while waiting for him, he was actually asking, what are the characteristics of great process mining tools? Interesting one.
Yeah, good point. I think probably there are two aspects. One is, for example, the ability of interconnecting process mining with performance measurement. So, in my opinion. And I'll mention something in the second part about how you should compare the observation that you can get from the event log in a sound way, because this is a part that, in my opinion, the community don't have yet investigated well. So we compare results, for example, the performance that I have in a variant with another variant, but how can I know if the comparison is significant or not? And this will be a part that I will mention in this second part. From the algorithm point of view, the big challenge is the right conciliation of the quality metrics that I presented, like precision, fitness, generalization, and simplicity. There are also other quality metrics that was proposed, but these four are the most commonly used. And developing techniques that allow you to balance between them and to understand which could be the right balance to be used in a specific case, this is an important challenge today for the community and for the process mining tools.
Okay, I will ask you one question and then keep the other for the second session. Alia asked about can process, oh, okay, I have someone raising hand. Okay, Mas Abdurrahman, would you like to ask yourself, please? Abdurrahman? Oh, is this? Okay. Wrong button. All right. Okay. Well, I will continue asking the question of Alia. Can process mining be used for predictive purpose? If yes, is there any tips or something to keep in mind?
Yeah, so a lot of research activities are going exactly in this direction. So, for example, I know just a part of the case. The case is not yet complete. And I would like to predict the lead time of this case or the costs that will be required or the resources that should be made available in order to complete the case. So there is a lot of research that is going in this direction using, for example, predictive algorithms from machine learning, neural networks, and so on. A big challenge that is faced now by the community is something that we discussed today at the ICPM conference. We organized a workshop, about machine learning and process mining. A big challenge is understanding how I can correctly configure, for example, deep learning algorithms in order to deal with event logs. Because as we have said, event logs are using a representation format that is a little bit different from what is used by the machine learning community. I don't simply have events, I have events that are grouped by case. This is an additional level of complexity that must be somehow managed. And people are trying to going on this topic right now, because you have many results about doing predictions using the data that you have in the event log, but they are not really exploiting the structure of the event log. They are using for example, the performance that are attached to the single event, but not to correctly addressing the cases, the variants, and so on. So this is today one of the challenges.
All right. We have several other questions, but I would allow you to share the extraordinary of process mining, then we will take more questions.
Yeah, thank you so much. I think this part will partially go in the direction that was, let's say, touched by the question that was proposed, because exactly the point here is understanding how can we effectively use, for example, the variance in order to do a fair comparison between the data that we have in the event log. So we said, okay, a variant is a collection of cases, but this notion could also be relaxed, because we could define a variant as any set of cases that are conforming to a specific pattern. No? For example, I take all cases with a cycle time efficiencies below 0.5. This is a segment of the event log that is going to describe a set of cases that are similar for some respect. So in this sense, we can consider them variants, or in the sense that they are similar cases. Or, of course, we could include multiple dimensions. So we could include the control flow, that is the sequence of activity, but also including additional elements like TT performance, cycle time efficiency, as an additional element that will allow us to define TT variants. I could also look for specific control flow patterns, like all the cases that include work activity and stuff like this. So once we have identified a variant, we can compute a performance indicator for this variant. And here you have two approaches. So one is you simply compare it with with an objective. So you know that the objective that you want to achieve is the following. So let's now observe if we have reached the objective that was defined by the organization. And this is not so complicated. So an example here, no? Let's say that you want to compare variant 1 with cycle time efficiency 0.5, and the objective level for the organization is 0.5. So you compute the delta, you may consider a tolerance, and you verify if the delta is below the tolerance. So it's quite easy in this case to verify which variants are meeting the objectives that was defined. And this can also be done using frequency. So instead of using the values of cases, you can simply use the frequency. So how many repair activities I have in a specific variant, no? So, and this is quite easy. But what about if you want to compare the performance level that was obtained by a variant with the performance level that is obtained by other variants? This is much more complicated. Because in this case, we cannot simply say, okay, let me compare the performance that was obtained by Department A and Department B. Or a very common example is the following. Let's take, for example, a human resource. No? So I want to consider all the cases that was performed by a specific human resource. And then I observe that the cases executed by this human resource has a lead time execution that is higher than the cases that are executed by another human resource. So you could say, okay, I have identified a difference between these two segments. Now, in this case, the two segments are the cases executed by the employee E and the cases executed by employee B. And because there is a difference, so I understand that the reason for these different results in the performance are related to the employee. It's not so easy because, of course, you could have many other dimensions to be considered. And I will show you an example later that can show that, for example, the reason could be simply that the employee A is working in the morning, and in the morning the lead time is higher than in the afternoon because, I don't know, for example, you are receiving the new materials, so you have to prepare the materials for executing the production line, and so the performance in the morning are lower than in the afternoon. So you compare two workers, but the two workers are not working in the same condition. So in order to developing fair comparison between different segments of the event log, you need to reason about the significance of this comparison. And you have one level that is the epistemic soundness, that is related to the fact I'm using a correct method in order to compute the performances, in order to compute my metrics. You may have a statistical significance, so is the difference that I am observing between the two variants something that is maybe due by chance, or is something that has a statistical significance. And finally, you also have a business significance, no? That is about if what I'm measuring is related and supported by the business goals. So all these aspects should be considered. For example, okay, so we already say, no, epistemic soundness is about the methods that I'm adopting. For example, is data collection safe? Is the analysis that I'm using consistent with the area of research that I'm using? You have statistical significance. For example, you may be interested in the sample size. You have very few examples. You know that this will not result in any significant conclusion for you. You may consider the variability. How variable is this result? No? We already said, okay, we can take, for example, the mean value, but the mean value may be generated by very different distributions. So if I have a distribution with high variability, this mean value will be less representative. And you can reason about the effect size, no? That these are a little bit the typical aspect that you consider in any scientific experiment. So we should also think about performance measurement in organization with more attention for the scientific method and the, let's say, requirements that the scientific method is asking us. And of course, you have the business significance, because someone have to tell us if the comparison is consistent with what the organization want to learn about itself. No, this is consistent with our strategic goals. So about statistical significance, you have, a big literature about tests that can be used for comparing data. I would like to show you just simple examples that, in my opinion, give you the idea that it is possible to do something also at the level of performance measurement. For example, let's use a metric like the lift metric that is used in association rules. No? This metric is going to compare the frequency of two events with, considering two events like independent, and the frequency of observing the two events together. No, so in this case, basically, you have a conditional probability, that is the probability of having the two events together, that is compared with the probability that you will have if the two events are independent. So if the two events are independent, you simply have to do a multiplication between their frequencies in order to have a conditional probability to observe them in conjunction. So by comparing these frequencies that is done, let's say, by chance with the real frequency that you are observing, you can verify if the frequency that you observe is let's say, deviating from the what is simply obtained by chance. Now, in this example, you have a variant V1 that include the repair activities, and V1. So the repair activity in V1 has a frequency of 0.3, while for V2 you have a frequency of 0.1. So now you compare this with the frequency that you have for V1 and V2 in general, without considering this additional constraint of having to repair observation. So in the case of the variant 1, so the joint probability of having repair in V1 is 0.3, while the joint probability of having V1 in combination with repair in general is 0.5 by 0.4. In overall, you get this a lift index of 1.5. No, that tell you that basically the frequencies of observing the repair activity in V1 is a little bit more than the expected chance. So yeah, maybe it's possible that this correlation is significant. Or, sorry, let's, for example, use a method based on central tendencies. No? Central tendencies is basically about comparing the means that you may have for two observations. So a simple technique for compared to central tendency is comparing the central tendency, for example, the mean, with the standard deviation that you have. And again, this will tell you that what you observed in variant 1 and variant 2 is a little bit lower than the variance we have in the observed case. No? So is something that can also guide you in understanding if what you are observing is significant or not. In case you have scalar variables, so you may use simple significant tests that are used in statistics. No? For example, here you have this Pocock test that is computing two scalar values that, like, for example, I don't know, the lead time using this formula. No? And based on the result that you obtain, you have tables that tell you how higher is the probability that this was observed by chance. And this probability is called the p-value. No? The p-value tell you if this observation is, so how likely it is that this was observed by chance. We know that the mean, however, can, the mean and in general, the descriptive statistics may be generated from very different distributions, we already mentioned. So you may have also more complex approaches that are not using simple frequency or central tendency. So in this case, what you should compare is compare the entire distribution. So you have techniques that allow you of instead of using simply the descriptive statistics that are typically used for describing distribution, you have techniques that are going to compare the entire distribution. So for example, here using this Wasserstein distance, I compared the distance between two distributions described in terms of cumulative distributions. And this, I think, may be very useful in process mining, for example, for analyzing the cumulative distribution of a variant in front of another variant. No? If you simply take the mean, this is maybe not representative of the real distribution that you have. If you use a technique like this one, like the Westerstein distance, you are going to account for all the examples that you have in the distribution. But be careful when you analyze the correlation, because you know there is this very well-known paradox that is named the Simpson Paradox, that tell you that the values that you can get in a distribution, no, like this one, may be completely different if you analyze subsections of this distribution. So let's see an animation here. This is, for example, the regression that I have for the entire distribution. But if I analyze a specific subset of the distribution, I may have completely different regression lines. And this should be considered when we do some performance measures using process mining. So let's do this example. No? For example, I have two different orders, no, that we want to consider. So I have order 1 and order 2. And let me consider the workout, so the processing time that was required by the two. And in average, I can observe that they have different averages. So for example, the second product has a mean value that is only 57 minutes. So apparently is less than the first product. But if I organize now the distribution in a different way, for example, distinguishing which execution was done in the morning and which one was done in the post-meridian, no, in the afternoon. So I may have very different results. So I see, if you look here in line 1 and 2, you have in the bracket, the square, you have the absolute frequency. Now, for example, I had 36 observations for the first product and 39 for the second product. The two sides are comparable, so I could expect to have results that are compared. But if I now observe them, distinguishing the observation that was done in the morning and those that was done in the afternoon, I may have completely different results. Because, for example, the second product is mainly executed in the afternoon. You can see that in post-meridian, so where I have a P in line 6, I have 29 observations, 29 cases that was collected. While in the morning, I have only 10. While the first product, line 3 and 4, was mainly executed in the morning, because I have 20 executions in the morning and 16 in the afternoon. And because in general, the time required in the morning is higher, you can see that actually the second product has a lead time, a workout time that is higher. Now, because if I consider the morning and the post-meridian, I have higher values for product 2. But by combining the two, I obtain an overall value that tell me that the workout of product 2 is lower. So you should always consider the way you want to analyze your data, not the dimensions that you want to analyze. And okay, so this is another example with the percentages, and but so it's similar. No, okay, so the message to take home is we need to be aware of what we are comparing. No, not any comparison can be considered valid, and try to use scientific methods in order to evaluate if the comparison that you are doing between different segments of the event log are significant or not. Okay, so here is another example using a chi-square test. I don't think we have time for entering into the details of this example. Another point that I would like to point out, I already quickly mentioned about this, but remember that from an epistemic point of view, in process mining, we have an important dilemma that we have to consider. Because if you are comparing the model, the event log, and the system, so the real system that you want to model, the organization or whatever, we should be aware that we have many subsets that may not be really relevant. No? For example, in the subset 1, you have the behavior that is modeled and is also observed, and is also something that is truly available in the system. So this, of course, is the ideal situation for us because we can compare our models, we can compare our event logs, and we know that the results that we will obtain are relevant for describing our organization. But you may have many other situations where this is not true. Now, for example, in the segment 6, you have behavior that is not modeled, is never observed, but is part of the system. So you may have also this kind of situations. No? So in this case, using your models, your specifications, or using your event logs, you will never be able to capture this kind of behavior that is, however, a behavior that is part of the system. Or you could have a segment like, for example, 5, where you have something that is part of the system. It was modeled, but it was never observed and recorded in the event log. This is a situation, like we said before, where you could understand that, okay, so in this case, because this behavior was modeled but never observed in the event log, we maybe would like to revise our process in a way that this specification will be met, no? And we would like to include this kind of behavior in the true execution that the organization will. But we may have also, we may be in a situation like 4. In a situation like 4, we have modeled this behavior. It was never observed in the event log, but this behavior is not really part of the system. It was modeled, but is not part of the system. So by observing the event log, I could say, okay, look, because this was never observed, let's modify our specification because our organization is not truly behaving like this. So this is really important, no? Because we have to understand clearly that what is returned by the algorithms that we are using in process mining is meaningful only if we have a research method and a research line that tell me what I want to achieve, what I want to obtain in terms of knowledge acquisition. So I need to have a strategy of knowledge acquisition that help my organization in using the results of the analytics and, for example, process mining, but analytics in general, in order to improve my knowledge. If I miss this general methodological approach, I may start using the results that are provided by analytics in the wrong way, because I could enter in a situation like this one where we are, for example, segment 4 or in segment 5. So at the end is the designer, is the scientist that has to guide the knowledge acquisition process. And yeah, okay, so Now, we can a little bit summarize this by saying that one of the choices that the designer has to identify is, for example, is the process that we want to model is a normative process, so there is someone that decided the process because, for example, is a regulation that applied by law. So in this case, if I observe something different in the organization, this is a behavior that should be removed by the organization, no? Because we want to comply with this normative specification. Or is the process that we are going to model is an emergent process, in the sense that we don't really know the process. So we want to use the data in the given law in order to understand something about the process. This is a very crucial design choice that we have to clarify at the beginning of any research activity that we want to do. Another important point is about stationary or non-stationary process. No? A stationary process is something that is always repeating in the same way. A non-stationary process is a process that is evolving due to some external condition. So if I'm working with the stationary process, new behavior that is observed in the given log may be a behavior that I want to include in my specifications. If I'm working with the stationary process, probably the behavior that is deviating from the specification is dysfunctional. Another aspect is understanding how, which is the variability I have in a process. No? You may have processes like production line where you expect to have very low variability. So everything is outside the expected is probably dysfunctional. You may have other example, like for example, collaborative process where the variability is very high. So the way you are using process mining metric is very different depending to these initial design choices that you have to define. And okay, so this was about reporting a little bit about what we have done in this workshop about process mining and machine learning, but maybe it's time to go for the questions.
Okay, yes, we can provide the slides to the audience. So if they are interested, they can get in touch with you later about this.
I hope in the slide you can find a set of reference and links that help you to go deeper in specific topics.
Okay. So yes, thank you very much. It's very interesting, but yes, as you mentioned, it's just about the time. So we will move on to answer the remaining questions. Afira, I will ask the other first, and then I'll get back to you because you have other questions as well. I would like to invite Pak Bayu. Would Pak Bayu like to ask directly? Pak Bayu? If not, then I will read out his question. What kind of specific conditions required to apply process mining efficiently and effectively? This is a hard question, but...
Yeah, so let's say the most straightforward way of observing process mining is you have some operational process. No, that typically is organizational process. No, like it would be the delivery of a product, customer care, I don't know, stuff like this. And you want to use process mining in order to optimize the performance of your process. No, so it will be like, for example, computing the cycle time efficiency of your cases, understanding why you may have problems, so where you have the bottlenecks, no, the waiting, the activities that are contributing more to the waiting time, where you have loops, where you have dysfunctional behaviors. So this is the most straightforward way of observing process mining. You want to use it in order to make your operations more efficient. So in this case, you expect that you may have some variability in the business process execution. So it's typically the process where you have the human inside. And however, this variability is not too high because you won't be able to identify, for example, the most frequent behavior, the infrequent behavior, and stuff like this. This is the very straightforward way of applying in process mining. Then people are using process mining also in areas where it theoretically is not so so well connected. Like, for example, in a production line. Production line, the process, the variability is, as we said, is much less. I expect that more or less I always have the same sequence. So analyzing the sequence of activities may be less interesting. In this case, typically people say, okay, the problem here is about configuration. Maybe I need to have some intelligence in defining how many resources I need in order to efficiently execute the production line and so on. But people are using process mining also in this context. And for example, use it in order to extend a little bit your ability of identifying the correlation between events. Because you want to observe the sequence of the execution, but also the performances. In this case, for example, you should not use the standard definition of variant, that is variant as a sequence of activity. In this case, your notion of variant will be something that is also connected with performance. For example, those cases, those executions where the temperature of the machine was higher than a specific threshold. So in this case, I could start developing some analysis where I'm looking at the correlation between the temperature of the machine and the final quality of the product. Or people are also using process mining for measuring very unstructured processes where the variability is very high. So in this case, of course, for example, the model, the traditional model in terms of a BPMN is not very useful. And you will be more interested in, for example, defining only part of the behavior using, for example, rules, in a way that will allow you to specify the behavior, not in overall, but let's say locally, area by area, activity by activity. And again, probably your the notion of variant that you should use is not the traditional one based simply on the sequence of activities, but is a more general notion that may be based on I don't know, the information that is exchanged, the feedbacks that was required, and stuff like this.
Okay, thank you. Now, Lifran, I think Lifran's question is also related to one of Afira's question. Can you please ask directly?
Okay, good evening. Hello, Professor. I really want to ask something according to your presentation. In what case should we use replay technique, trace alignment, and behavior alignment, or they should be carried out together to detect the deviation? Thank you.
Okay, thank you. Is a quite technical question. So basically, replay and the most traditional techniques are replay techniques. Then there is alignment techniques. So alignment techniques tend to be very costly from a computational point of view, but perform better. So it depends a little bit on the complexity that you have in your model. So if you have a very complex model, probably you should use alignment techniques. But you also have to know that these alignment techniques are more costly from a computational point of view. So if you have very complex models, they could become intractable. While behavioral techniques are, let's say, a little bit younger field of research that is providing interesting results. But so I say that probably for a standard project, any approach could be fine. You should start to differentiate between these different approaches if you enter in some more complicated scenario. For example, you want to do online conformance checking. Online conformance checking require adapting these techniques because these techniques are conceived to be multi-pass. So some techniques can be adapted in a way, other adapting in different ways. So you should start to understand which is the pro and the cons of the different techniques. But if you do, let's say, a standard project, I not see a big difference between one or the other.
All right. Okay. So we still have some more questions. So I would like to read out the one from Pak Hamza here. Oh, wait, Hanif. There were 4 technique discovery processes, such as alpha minor, heuristic minor, and so on. So I want to ask, are the 4 techniques still used, or should we use the heuristic minor / genetics techniques?
Yeah, good point. So about this, I would like to refer to these slides. This is a study that we have done in our lab about comparing different discovery algorithms. A first limitation that we have to mention is maybe the person that asked the question is aware about this. So these techniques that I mentioned are the most common techniques that are used, and you have algorithms that are available in, let's say, standard libraries and so on. So if you want to run a benchmark, it is possible to do it because you have the algorithms for implementing these techniques. There are much more advanced techniques that was discussed in the literature, but it's not so easy to compare them because for example, now you don't have a implementation in the process mining libraries that are used, or so the code is not available and so on. However, staying on these, let's say, more traditional techniques, yes, you can say that in general, inductive miner, you see here we have 3 versions of inductive miners that are the 3 versions that are available in the PM4Pi library. In terms of fitness, they are among the best, they provide the best results. Now, this is a study that was conducted on more than 1,000 event logs. In terms of precision, alpha miner and heuristic miner are good, but precision may be a little bit misleading, no? Because precision is about to say, okay, I'm able to, in my model, I'm able to generate behavior that is the behavior that was observed in the event log. So the model is not generating more behavior. But this is not enough to verify the quality of a model. Fitness is a little bit more significant, but still you need to have generalization and simplicity to be considered. And you can see that in general, inductive miner is balancing better these different dimensions. No? For example, this inductive miner that is using frequencies is probably among the best solutions if you want to compare the let's say, a trade-off between all the different dimensions. Time is not very performant, but so if you don't have a very high data dimension, it could not be a problem for you. of course, let's say you are interested in very high precision, so maybe heuristic minor is better, or also alpha minor may be better because it provides you a good, let's say, good time. But yeah, in general, it is also considered that inductive minor is providing models that are more understandable and sound in terms of the human readability. So I recommend to go for inductive minor.
Thank you. All right. So I think we will try the one last question. This is from Pak Hamza. How easy is it to get a reliable, clean, and accessible event log data? Is it always readily available within the organization's ERP? Should executive include the event log management as one of mandatory requirements when setting their ERPs or other automation systems?
Yeah, very good question. This, of course, is another challenge for the community, because not always you can rely on event logs. So an important part that we didn't mention in this presentation, but a very important part of the activity will be starting for your data in order to generate sound event logs. Yeah, so if it is possible to let's say design your systems in a way that they generate event logs, I think it could be a very good idea. And you have more and more companies that are going in this direction. However, yes, not always the event logs are available. So the data manipulation and data preparation part is a key part of the success of a process mining initiative, or a process mining project.
Okay, thank you very much. So
I don't know, maybe if I can mention one last thing about this. Now the community is working on a notion that is the notion of object-centric event logs. So the idea is that you may have event logs where you don't have a single case ID, but you can generate multiple case ID based on how you are grouping basically the events. So you could have a case ID that is related to the people that executed the activity, another one that is related to the product that was delivered, and so on. So it's like generating multiple views on the data, generating different event logs that are describing the same data set, but with different cases. So now the community is investing a little bit in this direction for so providing techniques that are adapting better to the fact that maybe you don't have a case in your data.
All right. Okay. Okay, then. I think it's because of the time as well. I have to stop here, but I would like to thank again Paolo for a very insightful session. And what I take from your session is that maybe process mining as it is a tool. So basically, when we use it, we need to really understand first what is the purpose of using process mining, and also, as always, data needs to be analyzed properly. So very insightful that you combine it with machine learning. So in that way, we don't always consider just the average, but also other characteristics as well. So thank you very much again. I would return this floor to the Master of Ceremony, Bu Ika.
Yeah, thank you, Bu Mahendra. I believe that this was a great and insightful session, because there are a lot of questions that have been answered yet due to the time constraints. So for all the participants, let's give an applause for Mr. Paolo by giving your reaction. Yeah, thank you. So thank you very much for Mr. Paolo for the insightful and sharing knowledge. So this is the end of the session. But before that, please, for the audience, could you please turn on your camera and we can take a picture together. Mas Rio, could you please help?
Good
Bisa
idea.
dibantu, Mas Rio?
Do you also have something to give?
Oh, wait a moment. I think I will give to the email because I love this file at the
All
moment.
right. Okay. So we have a little certificate for you, but we will email it later.
Oh, thank you so much.
Yeah, thank you.
Thank you so much.
Okay, yeah.
Right.
For the slide one, ready? 3, 2, 1. Okay, sudah di-take, Mas Rio?
Okay.
Yeah,
Sudah.
okay. Thank you very much for all the participants here and again for Mr. Paolo. So see you at the next GUELIS event. Thank you very
And
much.
let me have the picture because I will attach it in my office.
Okay,
Yes.
okay.
Of course. Okay.
Yeah, okay.
Bye
Thank you
bye.
very much. Yeah,
Thank you, Paolo. Thank you again. We will be in touch.
yeah.
Okay.
Terima kasih semuanya.
Terima kasih
Great
semuanya
pleasure
sudah
and great
bergabung.
organization. Thank you.
Thank you very much.